All right, let's do the test. So hopefully you can hear my voice here. Right. That's you anyway. Okay. Okay, I haven't changed my background. Yeah, better. Okay, so thank you for coming. Okay, let me start the recording. Okay. Right, thank you very much for coming. So today we'll be talking about topic OSPF, and then this time it is the topic is how to make your OSPF stable. Actually, there are lots of parameters to make your OSPF stable. Yeah, and then one of the parameters that will be discussed tonight is uh, uh, the choosing network type. Okay, so that will be discussed tonight. Okay, let's start. Let me share the slide here. Okay, so here it is. Right. Yeah, so this is the OSPF. This is the topic that will be discussed tonight. Okay, so this is our agenda. We'll be talking about, we do the preview, OSPF, and then discuss the OSPF network. Okay, so I don't think it's going to be taking much time. Okay, since most of you, I believe, already have some knowledge about that. Okay, introduction. We are GLC, Kadalitas Cakrawala. We are based in Bandung. We are doing training and IT consulting. We do MikroTik, Ubiquiti, and then we are we are doing MikroTik, Ubiquiti, Linux. We also have our own products, GLC Radius Manager, and then we do regular events like what we are doing tonight. My name is Ahmad. I'm based in Bandung. I do those things, doing MikroTik, set up networks, set up Linux server, and then we develop some application, web-based, mostly web-based application. Okay, so if you have LinkedIn, and then we can connect here. All right. So this is our past experience. So mostly our experience related to what is it? Networking. Yeah, most of our clients are ISP. So we do the routing, set up the server, and develop applications related to that, either ISP or telecommunication. Okay, so thank you very much for coming. Appreciate your attendance here. So I believe you are from Indonesia and then from overseas. Thank you. And then so here are the prerequisites. So we assume you already know TCP/IP. Of course, you already know MikroTik, and then routing protocol, routed protocols. Okay. Okay, let's do review. We already know that we have 7 OC layer. Each layer has its own protocols. Yeah, and then here's the process of encapsulation when you send a packet, when you send the data, and then when the data arrive at the destinations, and then there will be a decapsulation process. Okay, so you are peeling one layer one by one, and then you get the data. And then, so as you can see, we have lots of overhead here. So this is the data that we're sending. Okay, but actually this is the data that is really sent. Okay. And then here's the router and routing. Okay. Router is the device, routing is the process, and then here's the physical topology. And then based on that physical topology, we develop the logical topology, which consists of layer 3 information. And then here is some example of how the forwarding packets is done using routing tables. So packets arrive, looking up the routing tables, and then sent to the gateway. And then here's one example. And then, yeah, this is the routing. This is the place where routing table happens. And then, oh yeah, yeah, because we talk about the routing protocols, okay. So we also talk about the administrative distance in every routing entry. Yeah. Okay, so this is the routing administrative distance. So the lower the distance will be win. Okay, so yeah, the algorithm for choosing the best path is the first is prefix and then the second is administrative distance. If both are same, and then there will be arbitrary selection. Okay, so this is the routing static. And then if the routing static, all the routing entries will be done by the human. Yeah, so as an admin, you have to enter, you have to log into your router one by one, and then add the what is it, the routing entries. Yeah, so with dynamic routing, it's more automated. Yeah, you have to configure the dynamic routing. Of course, you have to, as a consequence, you need to know how the dynamic routing works, either RIP, OSPF, or BGP. Okay, so next is the things that you need to know is the asymmetric routing. Yeah, so routing is done one way. Yeah, either outbound or inbound, and then there is no guarantee that incoming path is similar to the outgoing path. Okay. Okay, so let's talk about the OSPF. So OSPF is a dynamic routing protocol. It's a link state. Okay, it says here. Okay, Dijkstra algorithm, and then it is hierarchical routing. Okay, using area, and then this is the IGP. Okay, so all interior gateway protocol. So all router must have a same AS number. So we do OSPF inside our AS number. Okay. And then version protocol number 89, millions organizations already using it, support load balancing. Need to consider, yeah, of course, because it's more complex, it requires more CPU processing. And then it's, yeah, lots of options, yeah. As you can see, you need to understand how it works, okay, especially what does it mean by hierarchical routing, yeah. So how is it compared to RIP? Okay, so this is how OSPF works. So this is how it happens. Okay, so first is find the neighbor router using the hello packet. So each router send the LSP and then LSA. So LSA will be flooded to all routers. Okay, and then each router generate link state database based on the LSA. So this is the difference between link state versus what is it, distance factor. Okay, so distance factor, for example, is BGP or RIP. Link state is the OSPF. So it's a big difference. So if you are using distance factor protocol, so what you care is the router next to you. So another router after the your hop is not your responsibility. So this is my routing table, and then this is my routing table. I give it to you, okay, and then I just receive routing tables, routing entries from my peer, okay. So that's how it works, okay. That's how it works, the distance factor. But link state is not, okay. So whenever a changes happen in the network. For example, a cable is down, okay, is cut down, or the link is down, and then that means a changes in network topology. So for that one, we will send all the LSA to all routers. Okay. And then need to know that the area ID, authentication, hello interval, and that interval must be similar among routers. Okay, about the network itself. So in the OSPF, by default, there are three types of a network here. First is the broadcast. Yeah, that's a default. Okay, and then NBMA. So yeah, the problem about broadcast is broadcast. That's the easiest way to find out your peer. Okay, in the same segment of the network. Yeah, but yeah, the thing is broadcast. Yeah, so some networks they don't like it, the broadcast. Okay, and then so the second variant, the next variant of the broadcast is NBMA. So it's a non-broadcast multiple access. So that the network is able to do multiple access. So it's not point to point, but 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 they are um, they are not using broadcast. Okay, so it's you who define the selection of DR router and then BDR router. So we will discuss about DR and BDR later. Next is point to point. Okay, either point to point, two hosts, or point to multi point with multiple hosts. So this is the question. So which one is more stable? Yeah, we'll discuss it later. Okay, please hold on. So so we already discussed here the broadcast and NBMA. So this is how it works. Okay, so as you can see, here is your broadcast domain. Okay, so your broadcast domain. So your layer 2 segment. Yeah. Okay, so here you have a routers, and then it is not efficient if you tell all of them. Okay, so router 3 will inform its routing table to router 4, to router 5, to router 6, to router 2, router 1. Okay, it's not efficient. So the way they do is they create a concentrator. Yeah, it's a hub for routing coordination. Okay, so here we have a DR, then BDR. DR means designated router. BDR is the backup DR. Okay, so all router only communicate to them. Okay, here and then. Okay, so in the communication link, this is more efficient. So it reduces the mesh connection. Mesh connection means all routers needs to connect to all other routers. So each router needs to connect to all other routers. Okay, so we are avoiding the mesh connectivity. So this is how it works. Yeah, so router will do election, okay, to choose TR and BDR. Okay, this is to reduce LSA. Otherwise, router 3 will send LSA to here, send LSA to there, send LSA to here, 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 and router 4 as well, here, 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 and here. Okay, so we want to avoid those LSA flooding into the network. Yeah, so this is how election starts. So it's based on hello packets. So first router become DR, second router become BDR. So and then you can see the status on the OSPF parameters. Okay, so next is NBMA. So it's similar with NBMA is using DR and BDR, sorry, for routing coordination. Okay, so we have a router, DR router here, and then BDR router, and then those routers will be used for coordination. So every routers will just send their LSA to those things. So would you say this is non-broadcast, but they still do DR? Yes. So they are still using DR, but they are not doing election. Why? Because you are the one who is electing, who is informing the routers who is DR, who is BDR. Okay, the priority. So So that's what it is. That is for using. That is that way we can avoid the election. Okay, so no broadcast. Uh, yeah, there will be a election as well. Yeah, to DR and BDR. Yes. Sorry, I said. Um, uh, yeah, there is a process for electing DR and BDR, but but uh, there is no broadcast here, so we can avoid the broadcast way to elect the DR and BDR. Okay, so that way you have to define. Okay, so this why we don't need the broadcast, because at router 3 here. So when you use NBMA on each router, you define this router will connect to this, the router connect to that, this router will connect to that, here and there. So the total number of routers in that segment is already defined one by one. And because it's so, you don't have to do the election. Okay. So we do, sorry, we don't have to do the broadcast. So why we do broadcast? Because we don't know how many routers in our broadcast domain. Okay, so that's the reason why we do the broadcast. Okay, we don't know how many routers in this broadcast network, either 3 routers, 4 routers, 5 routers, we don't know. So that's why we do the broadcast. And then, but because broadcast is not efficient, okay, maybe, yeah, in some cases, it's not allowed to do the broadcast. Yeah, so that's why instead of broadcast, we set up the NBMA. Still, they do DR and BDR. They do election DR and BDR, but no broadcast. So that's the big difference between broadcast and NBMA. Okay, the next is PTP. As here you can see, I got the picture from ipcisco.com. Actually, this is the open standard, the OSPF. So here there is no broadcast and then no election at all. So that's the that's the I think Vera, if I put the summary here, yeah, to have a table that shows the difference between PTP and NVMA and then the broadcast. Okay, so this is the broadcast. Okay, here. Okay, so this is the broadcast. We are using multicast. Okay, so 224 dot something. Yeah. So only we send a multicast packet to the routers. Okay, and then we have NBMA. Okay, still NBMA we are using like unicast. Yeah, we don't need the broadcast, because how do we know this unicast here? Because on every router we define the peer manually, so we don't have to worry how many. So every router do not have to check how many routers in the network. Still, NBMA they have DR and BDR election, similar to broadcast here. Okay, so the next type is the point-to-point. This is very simple. Okay, so they are using a multicast. Okay, no broadcast. Okay, usually applied in a point-to-point. Okay, and then it is also possible here. Okay, so this is point-to-point on the 2 hosts, but this PTP can be implemented on point-to-multipoint. Okay, yeah, yeah, it's possible. Yeah, for example, a point-to-multipoint, a non-broadcast, for example, you can apply here on your VPN connection. Yeah, it is possible. And then based on our experience, this is the most stable network type that you can use to apply on your OSPF network. Okay. Yeah. So even though it is Ethernet, yes, even though it's more than one routers or more than 2 routers, 5 routers, 4 routers, you can use a PTP. Okay. Any questions so far? No? Okay. Yeah, so the problem with the DR and VDR here, based on our experience, is sometimes in the network, you have two DR. So this router becomes DR, this router becomes DR. So there are two designated router in same network. So yeah, that happens. Okay, especially when you have a problem here in layer 2 here, layer 2 problems. Okay, when they connect, and then there will be two DR. Yeah, and then if they are two DR, they have two DR. Yeah, sometimes you have to restart the routers or you have to restart the OSPF. Yeah, actually restart the OSPF and then they will do synchronize and then everything back to the normal. Okay. So how about the um, settings in the router OS? Well, we can see it here. Okay. Okay, so this is one example. This is my test router. So as you can see, this is the routing SPF. I'm using version 7, router OS 7. So here you can use templates, and then on templates you can see the network type. Here's the broadcast, here's the NVMe, and then here's the PTP, either PTP, PTMP broadcast. So this is a new variant. So previously in version 6, it's only PTMP and PTP. Okay, and then here's the PTMP broadcast and PTP unnumbered. So this one I haven't checked it yet about the I haven't tried yet. So the things that I usually use is PTMP, either PTMP or PTP. Yeah, that's the example. So for NBNMA, so you can check it here. Static neighbor. So this is how you define the NBMA. Okay. So in version 6, there is a special menu called NBMA. There you can define the peer router, the router next to you, so that you don't have to do the broadcast. Okay, but with the NBMA, here's the thing that you have to define. So here's your routers. 10.10.1.1. Okay, so here's the instance, and then here's the polling interval. Either every 10 seconds, they are checking the. Oh, okay, so I cannot use it. Yeah, the IP address needs to be aligned, but that's fine. Okay, so we can do it next time. Yeah, but the thing is, at least you know, based on our experience, um, if you want to have a more stable link, stable OSPF link, either pick PTP or PTMP. Why the broadcast and NBMA is not preferred? Because they still do the DR and VDR. Okay, and then sometimes, not often, sometimes it happens. So if you have a layer 2 problems between the routers, between two routers, even the routers only two, and then yeah, it can cause a problem. It can cause issue during the exchange, routing exchange. Where is my slide? Oh, there's my slide here. Oh yeah. Okay, yeah. So yeah, so that's all for today. Thank you very much for coming. So Any questions? If you have a question, and then please type in a group chat. If not, and then I think we are done now. And if you're interested, please come to our training class or inform our email, or inform our what is it, admin for if you're interested. Okay, so I think that's all. Again, thank you very much. Okay, so if you want to submit feedback, if you want to what is it, if you have an idea about the topics, and then you can put them here. For further events, they'll be on our website. Facebook is available as well. Slide will be available on SlideShare. Discord is also available, and then recording will be uploaded on YouTube. All right, guys. So again, thank you very much, and then have a nice day.